Artem Jivotovski on the AP test is filling up the holy spigot with water. Water pours out of the hose at a rate of 20x plus 30 liters per minute, and the tank has a maximum volume of 100 liters. How long will it take before the tank is full and Artem can resume blazing it? We can create a definite integral from time 0 when he starts pouring the water to time t when the tank is full. We set this integral equal to 100 liters, the maximum volume, and solve for t. The antiderivative becomes the function f of t, which is represented by 10t squared plus 30t equals 100, since the initial time is 0. Solving, we find two solutions, t equals negative 5 and t equals 2. Since time is never negative, we can disregard that answer. Therefore, the tank will be full at time t equals 2 minutes, and Artem will be back home in time for 4:20. Wait, rewind, let's see that again. Alright, so we have a 10-foot long ladder, and when we first see our dinosaur friend here, it's about 8 feet above the ground. Unfortunately for Mr. Dino, it's also sliding away from the wall at 3 feet per second. How fast is the ladder sliding down the wall and away from the dinosaur on the roof? We can use the Pythagorean theorem to find the distance between the bottom of the ladder and the wall at the start, substituting 8 for A and 10 for C. Solving, we find that B, the distance we're looking for, is 6 feet. So now that we have the dimensions of our triangle, we can find the speed at which the ladder slips down the wall. Let's take the derivative of the Pythagorean theorem and substitute in what we know. We know that the rate of change between the bottom of the ladder and the wall is 3 feet per second, and we also know the dimensions of the triangle. Considering that the ladder is rigid, its length won't be changing anytime soon, so its rate of change is 0. If we simplify and solve, we find that dA dt is negative 2.25 feet per second. This means that the ladder is falling at a rate of 2.25 feet per second when the ladder first begins to slip. Poor Mr. Dinosaur!
Now, we ride.
Iguanodog and Officer Pterodactyl are in a high-speed chase! Iguanodog's acceleration is 4 feet per minute squared. When he passes Officer Pterodactyl's station in the tree, he's traveling at a rate of 8 feet per minute. Officer Pterodactyl, starting from rest, has an acceleration represented by the function a of t equals 12t plus 4 feet per minute squared. The town is 22 feet away from the officer's post. Starting from Officer Pterodactyl's station in the tree, how long does it take them to meet? Does Officer Pterodactyl stop Iguanodog before he reaches the town? Since we're given both Iguanodog and Officer Pterodactyl's accelerations, we can easily find their velocities by integrating. Using integration, we find that Officer Pterodactyl's velocity is shown by the equation v of t equals 6t squared plus 4t feet per minute, while Iguanodog's is 4t plus 8 per minute. Using these functions, we can integrate further to find their position functions. When their position functions are equal, we know that's where their chase ends. Officer Pterodactyl's position is 2t cubed plus 2t squared feet, where Iguanodog's is 2t squared plus 8t feet. Since we're discussing their position in respect to the officer's post, their initial positions are both 0 feet. When we set these two functions equal to each other, we find three values: t equals 2, t equals negative 2, and t equals 0. Since time cannot be negative, we can eliminate negative 2. We also know that they start in the same position, with the officer being above Iguanodog, which eliminates the value of 0. So we end up with a value of t equals 2 minutes. That answers our first question, when their chase ends. Now we have to answer the second question. Does the officer stop Iguanodog before he reaches the town? To find this, we simply have to find s of 2, which is 24 feet. Since the town is only 22 feet away from their initial position, Officer Pterodactyl has failed to apprehend the malicious Iguanodog in time.
From out of the dust came a man true and bold, champion of the fandango. By night he drank whiskey, by day killed bad men, and the townspeople knew him as Rango. Coming down the mountainside, the people hailed his name, and of his legend they sang. Oh, with iron in his heart and steel in his claw, he pumped their heads all full of lead. Rango.